Okay, so with subsets, instead of listing them all out, if we notice that they're powers of 2, we can have this formula 2 to the k, where k is a number of elements. So this is 3 elements, 2 cubed is 8. 2 elements, 2 squared is 4. So if I have 1, 2, 3, 4 elements, 2 to the 4th power is 16. If I wanted to know the number of subsets or days of the week, there are 7 of them. So 2 to the 7th power, whatever that answer is. And then the empty set is kind of a weird one, but the empty set has nothing in it. So it's a set where it's literally there's nothing in it. But so if there's nothing in it, there are 0 elements. 2 to the 0 power is 1. And you're like, but what's the 1? Well, remember the empty set, there's always air, a little space with air in it. And so air is always a subset of that. Okay. One thing I wanted to warn you on some of the stuff we did in the other one, just be a little careful. 2 is an element of the set 2, 3, 4. That is totally true. But if I put little set things around it, the set 2 is not an element of 2, 3, 4, because this is a list of numbers and that's a set, and that set is not over here. The number 2 is, but not the set 2. But it could be true if I have set 2 is a subset, and then I have a list of a bunch of sets here. So set 2, maybe 2 with a 3 with a 4, and maybe a set with a 5 in it. Then I have a list of sets over here, and that set is on my list, so it is an element. Also be careful, if set A is 2, say 3, 4, 2 is not a subset of 2, 3, 4. Because it's an element, but this isn't a set. It doesn't have the little curly things around it. But if I put the curly things, then it's saying that 2, the set 2 is a subset of that, which it is, because if I have set 2, 3, 4, set 2 is a subset because it's like less than or equal to. So just be a little cautious on that. Those true false ones can get a little tricky. All right, on the next page, page 5, so when we're talking about sets, we have the universal set, okay, and I might have, you probably did Venn diagrams when you were a kid, so like maybe red and fruit. And so over red, you might have put a fire truck, maybe you have a red ball or a yo-yo, whatever, and then fruit, you might put bananas or cantaloupe, things like that. But in the middle is what they have in common, okay? And so what they have in common, might be, a red fruit, strawberries, watermelon, things like that, a red apple. Those are things that they have in common, okay? The universal set here might just be any noun, person, place, or thing. Universal set could be limiting. So it might be the universal set is Marvel movies, okay? And so in your Marvel movies, you have all your Iron Man and Spider-Man and all those, okay? If someone says, well, what about Wonder Woman? I want to watch her. Well, she's not part of this universe, right? She has her own DC universe, but not the Marvel universe. So again, the universal set is kind of what we're limiting our choices to, okay? Not is when you put a little, not an asterisk. What am I thinking of? A little hyphen on it. Is that right? Not a hyphen. Apostrophe. There we go. Sorry about that. It's been a long day. So if A is, my set is right there, then not A is the other stuff that it's not. Okay, so A might be all even numbers. So if you're not even, you're automatically out here, you're odd. Okay. Or A might be all the jobs that require, say, a college education. Not A would be all the other jobs that don't. Okay. So together A and not A make up the whole universal set because it's either, it does or it doesn't, and then you have the whole universal set. All right, so down here, not A means you take the universal set and you cross off A. So if I have the universal set as 1 through 10, and A is 1, 2, 3, 4, I'm going to cross off 1, 2, 3, 4. So I'm going to cross off 1, 2, 3, 4. Not A would be everything that's left in the universal set. So 5, 6, 7, 8, 9, 10, that set. Same thing for B. If B is all the odd numbers, 1, 3, 5, 7, 9, I would take my universal set, which is 1 through 10, and I would list it all out, 7, 8, 9, 10, and I would get rid of all my odds. So 1, 3, 5, 7, and 9. And so not B would be all the even things that are left, which would be the set 2, 4, 6. Oops, I forgot my 8. Good thing I double checked. 8 and 10. Okay. And so, you know, we can do math with that. All right, next page, page 6. All right, so this is the intersection, which is an and situation. If you kind of look at it's kind of curvy upside down U, and if you put a line in the middle, it kind of looks like an A. So this is an and. It's where the sets overlap. So this would have been like where our strawberries and, let's see, red and fruit would have overlapped, okay? Ands are kind of hard to get answers because they have to have it in common, okay? So if I think of A being all my mom's stuff and B being all my dad's stuff when they got married, what would they have had in common, right? Like maybe they both owned a car. Maybe they both owned a toaster, things like that, okay? And again, we don't list toaster, toaster, toaster. We just put the concept of toaster. All right, so let's look down here. A and B and universal set is 1 through 8. So where do A and B, what do they have in common? What's the intersect? Where do they overlap? What do they share? So if I look at A, 1, 2, 3, and B, 1, 3, 5, 7, it looks like they have a 1 and 3 in common. That is an and, okay? That is an intersection. And I could draw the picture, let's see, is this one I did? I did 1 in the middle and 3. So I have 1, 2, 3, but again, 1 and 3 they have in common. So 1, 2, and 3 are in A, 1, 3, 5, and 7 in B. And then every other number 4, 6, and 8 are in the outside of the universal set. So you can see the 1 and 3 is where they overlap. That's what they have in common. All right, now the other thing is I combine the not A and also do that with intersect B. So not A is 1, 2, 3. So I take my universal set 1 through 9, or sorry, 1 through 8, and I'm going to cross off 1, 2, and 3 because not A is going to be what's left. 4, 5, 6, 7, 8. Okay. Then I'm going to intersect it with what? B. B is 1, 3, 5, 7. And it's an and, so I'm looking for what they have in common, which is 5 and 7. Okay? All right. If they have nothing in common, they're disjointed sets. And the, you know, I guess they have the empty set in common. That's it. So if there is no legal answer, it's the empty set. All right. The next one is union. I like to think of marriage like a union. Brings a bunch of bunch of people together. Like when my mom and dad got married, they were married like 60 years. They had a lot of junk, right? When we cleaned out their house, whoo, yeah, they lived there 40 years. It was a lot. All right, so it's when you put it all together. It is an or. Ors are easier to get answers because either my mom had it or my dad had it or they both had it. Somebody had it. And so see how it's all shaded. I'm not just looking for what they have in common. I'm looking for either all my mom's junk, all my dad's stuff, or anything they had in common, okay? All right, and again, we can kind of do order of operations on these. So A union B would be everything in A, everything in a B, all mushed together. So A is 1, 2, 3, 4, 5. B has some of them the same. 1, 3, and 5 are the same, but then it also has 7, 9. So my answer is 1, 2, 3, 4, 5, 7, 9 in set notation. All right, B says A union with not C. So I have to take the universal set, which is 1 through 12 on this problem, and I'm going to cross everything that is C. So I'm going to cross off the 1, I'm going to cross off the 2, the 5, the 6, and the 9, and the 10. And whatever's left over is not C. Okay, so that would be what? 3, 4, 7, 8, 11, 12. But then I want to union that with A, which means bring it all in. Lots of junk. Put it all together. So A is 1, 2, 3, 4, 5. Some of those are repeats, right? But then I also have a 7, 8, 11, 12 from the not C part, okay? And so that's union. Union, ors are easy to get answers, super easy. And then I could do order of operations, A union B. We have that answer already, 1, 2, 3, 4, 5, 7, 9. And I want to intersect that with C. And intersect, again, kind of looks like an A when you put the line in there. So ands are hard because they have to have it in common. I'm looking for what they have in common. So it looks like what? 1, 2, and 5. Oh, and a 9. They have those in common. So 1, 2, 5, 9 is my set answer. If you miss these on my math hub, it's probably because you're not putting the curly guys around them. So make sure you do that. So again, union is easy to get lots of answers. That's pulling it all in, bring it all in, right? Putting it all together. So anything in A, anything in B, anything they have in common. Intersection is just what they have in common. So this is hard. And again, if you think of an or, like if you want a job, you know, and you want it in Iowa and you want it to pay, you know, $50K a year and you want to, you know, work 4-day work weeks and, you know, and, everyone, okay, that's kind of hard. Ands are hard. But if it's an or, it's easy. Or maybe you can find a job in Iowa. It might only pay $20,000 a year, but you can find it in Iowa. Or you get a 4-day work week, but again, you don't make $50K. Ands are harder. Okay, so ands, you usually have less answers because it's an and, ors. Only one of them has to fit, so you tend to get, you know, more answers that way. All right, let's look at the next page. Okay, so a real life example, let's look at this. Set A contains stocks with a high price greater than 34. So I'm going to look at the high price and high price greater than 34. So I'm going to cross off anything that's above $34. Got rid of all those. So not A would be all the sets, you know, all the companies that did not have a high stock value over $34. So if I look, that would be AT&T, looks like Disney, and Office Max would fit that requirement. So that would be my answer. All right, let's look at the next one. All right, and so on these like shading Venn diagrams, I'm going to do some example on a paper and then we'll come back and do some of these together. But if on these shading ones, say I want you to shade A, the complement of A or A naught intersect with B. Okay, so I could do this just by using colored pencils or by thinking. I have my universal set, here's A, here's B. So I'm going to shade not A. So this means it cannot be an A. So not A, I'm going to shade all the outside part of the universal set. So I'm going to shade everything that is not out there, or that is out there, not part of A. And then there's part of B that is not part of A as well. So if I have my Venn diagram, there's part of B that does not intersect with A. So see how A does not have any shading because I want not A. So if I put my finger in A, I shaded everything outside of A. Okay, now it says, okay, I'm going to compare it to B. So B, I'm going to put some, you know, stripe lines in here. B is all of circle B. Okay, this is an and, okay. Ands are picky because I'm looking where they overlap. This is the intersection. Where do they intersect? Where do they overlap? Well, the yellow shading and the stripes are just in kind of that moon part of B on the far right. So I'm going to make that a dark blue. So kind of that moon shape right there is what you shade. That is your answer. Okay, if that's kind of abstract for you, Lisa, who used to work in our AAC, came up with this idea, and I'm like, you are brilliant. All right, she took the two interlocking circles, our Venn diagram, and she put the number 1 on the left, 2 in the middle, 3 on the right, and a 4 out in the kind of the universal set part, okay? And what she did is she's like, well, you know, I'm just going to put numbers to this, okay? So do you see how set A has 1 and 2 in it? Set B has 2 and 3 in it. And the universal set has 1, 2, 3, 4. So then it becomes a problem like we just kind of did. Not A. All right, what's not A? 3 and 4. So the answer to not A is the numbers 3 and 4. Intersect. Okay, what's B? B is 2 and 3. So where do they intersect? And again, that's an and. It's hard to get answers. I want to know where those overlap. So 3 and 4, 2 and 3. They intersect at a 3. They have that in common. So then see how I still shade the 3 part. And I get the same answer I got by thinking abstractly. It's just that, you know, I didn't have to think as hard. All right, so we can do a trickier one with more values. So these aren't too bad. We might have to start the next videos with those. We'll see. A intersect B, that's an and. So where do A and B intersect? So I'm going to shade in the kind of like an almond shape between A and B. That's an and. Not very much is shaded. A union B would be easy to shade. All of A, all of B, everything they have in common. I would shade all that. Okay, this one's going to get a little trickier. Not A and not B. Where would that be? All right, and I think we'll start the next video with that one. And there might be some on the other page too, where once you get more going on, it gets a little tricky to just use colored pencils. You can, but I'll show you kind of how to do the paint by numbers on that.